Consider a local farm where both horses and cats live. 24 horses and 6 cats live on this farm. Compare the number of horses living on the farm to the number of cats living on the farm in multiple ways. Okay, so we've got 24 horses and 6 cats. So when we're going to compare them, you could say, you could really just say there are 24 horses to 6 cats. Like, that's one way. Well, we can also break this down. If you look at 24 and 6, those are both even numbers. So I could say, let's reduce, cut in half. There are 12 horses to every 3 cats, right? I'd cut them each in half. And, if you look at 12 and 3, well, they're both reducible by 3. So if we divide by 3, 12 divided by 3 is 4 horses to 3 divided by 3 is 1 cat. So there are 4 horses per cat. So that's kind of 3 different ways that you can think about the same information because we can reduce fractions. 40,000 vehicles were sold in a local city last year. 30,000 of those vehicles were cars and 7,000 of those were trucks. Make a few comparisons. Okay, so we have 30,000 cars, 7,000 trucks, 40,000 total. So, if we know that 30,000 out of 40,000 are cars, well, if you think about reducing those, the zeros will all cancel out. That means 3/4 of all vehicles are cars. That's one way. You could also think, same concept, 7,000 over 40,000, trucks over the total, get rid of the zeros. That means 7/40 of all vehicles are trucks. I'm out of space, but if we take 30,000 compared to 7,000, get rid of the 3 zeros on the end of each, and we could say there are 30 cars to every 7 trucks. So, and we could fill pages and pages of comparisons with these numbers. Number 1, let's flip on the page. Victor wants to eat dinner tonight at a local cafe. He plans to order a soda for $1.99, a beef sandwich with fries for $6.25, and 2 cookies at 50 cents a cookie. Okay, let's right now just figure out how much this is going to cost him. So, $1.99, $6.25, and $1, right? Because he had 2 cookies at 50 cents each. So his total bill is $9.24. Now, next sentence, 7% sales tax. Well, just think about sales tax. If my bill is $9.24, I'm going to multiply that by 7%. That's going to give me the amount of tax, which is 65 cents. So he's paying 65 cents in tax. So his total plus his tax gives him a bill of $9.89. Can he afford it if he only has a $10 bill on him? Well, yes, he can. Can he leave a tip? That's the second part. Well, if he pays with a $10 bill and we subtract $9.89, he can leave the waitress an 11-cent tip. Now, I don't know if you've ever been a waitress, but I would be, that's kind of a slap in the face. Really. And I understand that you only had $10 and so whatever. It's still a little bit rough. I would call that a bad tip. Number 2, a study shows that 9 out of 10 people prefer dogs over cats as household pets. According to this study, would your new neighbors be more likely to own a cat or a dog? And explain your answer. I hope this one is fairly easy to kind of comprehend and that we would expect a dog. 9/10 is 90%. That is well over half, right? It's definitely a majority. So because a majority of people prefer dogs, you would just think if they're going to have a pet, they're likely to have a dog. Could they have a cat? Sure, 10% of people like cats. Right? And number 3, when Brad leaves for work, he drives at a constant rate of 35 miles per hour. 35 miles per, gives us a division sign, per 1 hour. Adrian, who lives the same distance from work, drives at a constant rate of 50 feet per second. If they leave for work at the same time, can you determine who should arrive to work first? If so, how? And if you can't, what do you need to know? Okay, so this is Brad over here. And then we have Adrian, who goes 50 feet per second. And you might say, I don't know how to compare those. They're different. And that's legit. We are going to learn how to do this. But here's the thing. We need to change feet to miles, right? Because that's to compare Brad. And I know that there are 5,280 feet in 1 mile. That conversion right there makes my feet disappear. Look at me, I'm feetless. I also want to change seconds to hours. Well, I know there are 60 seconds in 1 minute, and let me crouch another one in here. There are 60 minutes in 1 hour. So minute cancels out minutes, seconds cancels out seconds, and now I have a math problem. Now, when you have a number, so 50 is in the top, so I start with 50. I'm going to divide by 5,280 because it's in the denominator. I'm going to multiply by 60 because it's on the top, and I'm going to multiply by 60 because it's in the top. When I put that all in the calculator, it gives me 34.09 miles per hour. Therefore, Brad's over here at 35 miles per hour. So because Brad is greater, Brad will get to work first. Not by much, but by a little. And the last problem here, I believe, number 4. Samantha is 54 inches tall. Paul is 5 feet tall. How many Samanthas and Pauls must be stacked on top of each other till their heights are equal? Okay, well, 5 feet, if I multiply, there are, in 1 foot, there is 12 inches. So that means Paul is 60 inches. Okay, so I have Sam and I have Paul. Sam is 54, Paul is 60. Now, there are a couple ways to do this, but I'm just going to use kind of the add method, right? The next one is 108 to 120. 162, 216. Nope. Sorry, 216 is on her side. 162 to 180. 216 to 240. 270 to 300. They're not the same. I'm going to go to a next line. I'm going to change colors for the next line. So I go, Samantha's now at 324, and Paul is at 360. Samantha's at 378. Paul's at 420. She's at 432. He's at 480. She's at 486. He's at 540. She's at 540. Hold the phone. There's a match. So you can see it takes 10 Sams and 9 Pauls for them to be the same, and that is at 540 inches. And that is, oh, I lied. There's number 5. I missed that on my paper. I last ate 40,000 seconds ago. Am I probably hungry right now? Explain your answer. Well, how long ago was 40,000? So 40,000 seconds. Well, there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So seconds cancels out with seconds, minutes cancels out with minutes. Because these numbers are in the bottom, we divide. Numbers in the bottom you divide, numbers in the top you multiply. So when I take 40,000 divided by 60, I get 11.1 hours. So if I haven't eaten in 11 hours, yeah, I'm probably hungry.